Hello everyone, I just wanted to show you a few parts of the parabola and how we identify those parts, so let's get started. First of all, the minimum or maximum, you only ever have one of those two when you're dealing with a parabola. We call this the absolute minimum or absolute maximum because it's the highest point or lowest point depending. So in this case, since we have the parabola facing this way, at number 1, that is a minimum, and that's an absolute minimum because this is the lowest point of the whole function. We also call this the vertex. And you call it the vertex whether it's a minimum or a maximum. Next up, I want to show you where the zeros are. We can also call these the x-intercepts, or they're also known as the solutions. If you remember, we factored recently and found the zeros because those were the solutions to the equation. That's why all three of these words are interchangeable. When you graph it, the solutions are simply where you hit the x-axis. So they're the x-intercepts. And in this case, we have two solutions. Sometimes parabolas have two solutions, sometimes they have one, and sometimes they had no solutions. But those are the only three options: 0, 1, or 2 solutions. Next up, we want to identify the end behavior. The end behavior is if you keep going out all the way to the left or all the way to the right, will the graph be positive or negative? With parabolas, because they're always shaped like this, the end behavior of both ends will always be the same. So in this case, both of these have positive end behavior. Going all the way to the left and all the way to the right means that your graph's going to be going up, so it's positive. This is a little bit different than increasing or decreasing vocabulary, so we have to be careful to distinguish between those two. Here, so the 3, that's the end behavior. This is also known as concavity. Concavity, meaning which way it is facing, can be either up or down, and the way I remember is it's up like a cup or down like a frown. In this case, our parabola looks like a cup, so it's concave up, where the ends are pointing up. In this blue parabola here, this is concave down. So we have negative end behavior, and the concavity is down. Notice the difference between end behavior and increasing or decreasing. I'm going to label two sides to my parabola here. On the left side, we're increasing, and on the right side, this parabola is decreasing. That's because when you're identifying what's increasing or decreasing, you're always going to the right, or increasing your x value. So on the left side, it's increasing because as we go right, we go up. And on the right side, it's decreasing because as you go right, you go down. This is different, like I said, than end behavior, where you're just looking at, if you go all the way left and all the way right, which way are we going? And that's down and down for end behavior. But up and then down, or rather increasing and then decreasing for that kind of behavior. We wrote this with intervals notation, like negative infinity, comma 3, with open parentheses. That is not a point, that is the domain that is showing how far left and right you're going. Remember, sometimes we show this with brackets that look like that, but in this case we want to go up just before we hit the vertex there. And the right end behavior would be 3 comma infinity. Another way to write that, which is my preference, is using greater than or less than, is x is less than 3, and for it's increasing on the interval 3 is less than x, or x is greater than 3. Last thing I want to show you is about the y-intercept. We'll go back to our red parabola for this. Notice that's the y-intercept, and you all know about that. The thing I want to draw your attention to is that that is the same as this value over here. And the reason for that is because the y-intercept is where x is 0. So if you consider f of 0, you plug in 0 here, or substitute 0, those two values go to 0, and all you're left with is that c term in the parabola when it's written in standard form. Thank you for watching, and I hope you learned something.